Okay, so let's look into this example 2 here. Okay, so question said okay, verify whether the A is can be diagonalized or not. Okay, so you look into this matrix. Okay, so obviously you can see that. Okay, is what? It's actually a lower triangular. 现在 is a triangular matrix. Okay, so if that is triangular matrix, so means your eigenvalue will be 3, negative 2, and 0. Okay, so if possible, I will always advise you, as I said, arrange from small to big. Is it okay? Arrange from small to big. Okay, so what does it mean then? Can it be new? Can it be diagonalized? Okay, because this is 3 by 3 and you have 3 different eigenvalues, so you must write has 3 distinct eigenvalues, so means A is diagonalizable, just like that. Okay, this kind of question will give you at most 4 marks. Okay, at least 2 marks. Okay. Okay, let's look into this example 3 here. Again, question want you to verify whether the matrix involved is diagonalizable or not. So if you find out this question, right, or these matrices is none of any pattern shows that it's a diagonal matrix or either the triangular matrix, so you cannot emphasize it directly. You get what I mean in that? You still need to reduce it, okay, until you have your reduced echelon form. Okay, meaning to say that you don't have any diagonal matrix or upper triangular, upper or lower triangular. Okay, so this is zeros, zero matrices. Okay, so if you don't have either of it, you need to do the solution until you have reduced echelon form. Okay, so this example actually is exactly the same thing as your previous chapter. Okay, your 6.1. Okay, example 6. Okay, so from what we have, the eigenvalues obtained is 133. So what does it mean? You have 2 distinct eigenvalues. If 2 distinct eigenvalues, okay, so how are you supposed to do? You cannot straightly, if you only identify about the distinct eigenvalue, not necessary it cannot be diagonalizable. You get what I mean in that? Okay, not necessary it is not diagonalizable. So what you should do, go back with your eigenvectors. So when lambda equal to 1, you have your eigenspace. When lambda equal to 3, you have 2 eigenspace. So total how many eigenspace here? Or the vectors involved? 3 exactly. Okay, so if you have 3, so means that you have 3 linearly independent vectors at the same time. What's the size of your matrix? Is 3 by 3. So it fulfills the main condition. So hence A is diagonalizable. So can you see the questions here? Okay, if let's say obviously like this one, obviously you already have 3 distinct eigenvalues. You can just treat, okay, A is diagonalizable. But if let's say at the first place you found out that you have only 2 distinct eigenvalues, you cannot strictly conclude that it's not diagonalizable. Okay, you need to find out whether you have any 3 eigenvectors or not. Okay, if you have only 2, unfortunately, then you can conclude already that it's not diagonalizable. But for this question, you have 3 linearly independent vectors, and at the same time your A is a 3 by 3 matrices, so that's why you can conclude A is diagonalizable. Okay, I hope you are clear with this. Okay, or some of you may like to check, okay, with the condition as well. Okay, can, why not? Okay, to double confirm, right? Okay, no harm to double confirm. So let's say your lambda equal to 1. So what is your algebraic multiplicity? 1, right? Because it have been repeat only one time. Okay, so only 1. So what is your geometric geometric multiplicity? Is 1, because you have only one eigenspace here. Okay, so you can see 1 1, so it's fulfilled. See not, it's the same. You get the idea? Okay, maybe you're not. Okay, I just put in words, I mean in diagram easier. Okay, so you see, for lambda equal to 1, your algebraic multiplicity is 1. Okay, your geometric multiplicity is also 1. See that? Okay, so it shows that it is the same. Okay, same goes with, okay, you check again when lambda equal to 3. Okay, I use different color of your, okay, okay, so how many distinct value for when lambda equal to 3? You have, sorry, not distinct value. Okay, algebraic multiplicity. Okay, you have twice, right? It's 2 because it have been repeat twice. Okay, so means that for lambda equal to 3, your algebraic multiplicity is 2. Okay, so how about the geometric multiplicity? Is also 2. See that? So here what you can conclude, okay, it is also the same. Okay, if also the same, so means A is diagonalizable. This one, A is diagonalizable. See that? This is another way for you to double confirm. Okay, okay, you can look into example 4. Okay, verify this. Okay, so we assume that we have done everything, class. Okay, okay, so let's say that, okay, we already found out your eigenvalues is this 2 negative 1 negative 1. So it means that how many distinct values here? 2, right? You have 2 different eigenvalues here, right? Okay, so after that, so we already know that when lambda equal to 2, your eigenspace is this. When lambda equal to negative 1, you have eigenspace is this. Okay, so tell me, how many linearly independent eigenvectors here? You have 2. See that? But you must remember, what's the size of the matrix here? Is 3 by 3. So, but you have only 2 linearly independent. So you can straightly already conclude A is not diagonalizable. Okay, I hope that with these 3 examples here, you can see the things clearly. Is that okay? Okay, so if not, you can also check, as I said. Okay, when lambda equal to 1, your algebraic multiplicity is 2, right? It's 2. But when the geometric multiplicity is 1, see that? So obviously it's not the same already. See that? In, how to say, in exam, right, you can actually no need to write in words, but whatever you have written must be clear enough. Okay, you can just straightly put in between, whereby it's not the same. Okay, so if that is the case, so A is not diagonalizable. So that's the answer. Usually this kind of question, right, it will this session will only stated, or when it will only ask at the end of a few sub questions behind. Okay, they will not like exactly or particularly only one question. Okay, usually they will have they will embark in the same question, but maybe towards the end, let's say the section D, E, F or something. Okay, so usually, as I said, minimum 2 marks, maximum can go to 4 marks. Okay, so that's all for the examples.